given notice that I've got a couple labels on the top and bottom sides. You know what these two arrows mean? They are parallel. These two arrows indicate that the two sides on top and bottom, AB and DE, are parallel. AB is parallel to ED. That has been given to us with those initial labels in the figure. Because I have some parallel lines, also going to have some congruent angle measures. This angle measure at angle BAC is congruent to this angle measure at CED. So let's write this down. Let's say this statement next. Angle BAC is congruent or equal to DEC by what are called alternate interior angles. Remember back to last year, when two parallel lines like that are crossed by a transversal, when two parallel lines are intersected by a transversal, we're going to have lots of matching angles that are congruent. One of those types of angles are called alternate interior angles. So alternate interior means a pair of angles between the two parallel lines that are on opposite sides of the transversal. So there's a pair of alternate interior angles. Those two angles are congruent because they're alternate interior angles. This pair as well, on the bottom right, top left. We basically have the same thing here. A pair of parallel lines running left and right. This is the transversal AE running across those two parallel lines. So angle DEC and BAC have to be congruent by alternate interior angles. There's another pair of congruent angles in the figure. So let's talk about that next. How about this pair of angles on top and bottom, where the two triangles kind of meet up in the middle? Those two angles are also congruent. Angle BCA. BCA refers to this angle on top. BCA would be the same thing as DCE. Why would those two angle measures be the same? What types of angles did I just use there? Starts with a V. Vertex close, like the vert part, vertical. They are vertical angles. BCA and DCE, this angle on bottom, are what are called vertical angles. Vertical angles come about when two lines intersect like that. When two lines intersect, it creates a couple pairs of vertical angles. Pair on top and bottom have to be of equal measure, as do the left and the right pairs. Also the same. Vertical angles. How many pairs of angles in these two triangles are congruent? We've just showed how many pairs of angles in these two triangles are the same. Well, isn't it just two pairs? Here's one pair that is the same. Here's a second pair that's the same. One pair, second pair. I think I've got it. Which of these similarity reasons on the backboard applies to these two triangles now? What's it go? Angle. In the second line, I said one pair of angles was the same. Line after that, I said another pair of angles the same. So these are two similar triangles by what is called angle-angle similarity. So let's name them. Triangle ACB, I'll go that order, is similar to triangle ECD. By angle-angle similarity. Down below here. In line 2, we proved alternate interior angles gave us the first pair. In the next line after that, we showed the two vertical angles were the same. So by angle-angle, those two triangles are similar. Did the first one. We've shown that those two triangles are the same. How about the next one? Got a pair of overlapping triangles, VWY and VXZ, that I want to prove similar. Are these two similar triangles, VWY and VXZ, the total figure? Well, let's redraw so I can know what goes with what.
Both have B's, there's one.
Mm-hmm. Absolutely, both share a common angle. Some side lengths have been given. Sylvie, what's the length of VW? 6. How about VY on the right side? Okay. What would those correspond with in the total triangle, the total figure, the larger triangle? VX would have a length of what? What do you think, Emma? 8. Can you do the other side? 12. Now that I've got it redrawn, I think it's a little bit easier to see what goes with what. We've got some side lengths, so let's look for some ratios. VW to VX. There's a pair of corresponding sides between the two triangles. VW to VX. What's that ratio? 3 to what? 3 to 4, because it's 6 to 8, which is 3 to 4. Okay? What you're using there is called substitution. You're replacing VW and VX with what they're equal to from the figure. VW has a length of 6, VX has a length of 4, so VX has a length of 8, so they're in a ratio of 3 to 4.
Side.
We will get there in a second. I got to look for other pair of corresponding sides, Tristan. What else could I do? What other pair of sides could I use as a ratio? How about VY and VZ? What ratio is that, Dan? Which is then what? Reduced down. She just replaced those side lengths, VY and VZ, with 9 to 12, which is the same ratio as 3 to 4. What do you notice about those two ratios? Say it, Tom. They're equal. So because they're both equal to 3/4, I can set them equal to each other. VW to VX is equal to VY to VZ. I substituted lines 1 and 2 together. VW to VX is the same 3/4 as VY to VZ. So since they're both equal to 3/4, can I just set them equal to each other? Basically, set those equal to each other because they're both equal to 3/4. Now I've got two pairs of sides that are in proportion. Preston, you were talking more about angle V. What do you notice about angle V?
It's on both the triangles.
What do you mean?
If one triangle's inside the other, it would share the angle B.
So don't they have a common angle measure?
Yeah.
The same angle V in the first triangle also shows up again in the second triangle. So wouldn't those degree measures have to be the same? Because they're using the same angle measure, the same angle. So in our next statement, I can say that angle V has to be congruent to itself by what's called the reflexive property. I'm writing down some of these statements that will show up on your Khan Academy practice, kind of getting you used to thinking about using some of these statements in hopes of proving two triangles are similar. Let's see what we've got so far. Two pairs of sides are proportional, and an angle measure is congruent. Back to my tool chest here, I've got the 3 ways to prove that two triangles are similar on the back wall. Which of these 3, I think, is going to do it for me now?
Side angles.
What's your side angle side, Caleb?
Because there's paired sides of equal.
Now the angle where it's at is important, right? If it's SAS, the angle has to be between the two sides. But I've got proportion. Side angle side. V is the angle measure between WV and YW. Or YV, pardon. V is the angle measure between WV and YV. What if I move that angle and put it here? Is that side angle side angle? What if I move the angle to the one in the lower left corner? Would that be side angle side angle? Why not, Tom?
Oh, because for angle.
Yeah, the angle measure is not between the two sides. Isn't this ASS now? ASS doesn't exist. It's side angle side for us to use. So now we've got triangle VWY is similar to triangle VXZ by SAS similarity, side and side. This line, we showed that I had 2 pairs of sides that were proportional. The line after, I shared that an angle measure between the two triangles was congruent. So by SAS, side angle side, those two side lengths, or those two triangles are similar.